I'll talk about songbirds a bit. Songbirds, some of you may know, but some people don't know that they learn their song. All right, so songbirds, there are over 5,000 species of songbird, and all of them learn their song from a tutor. So typically at a young age, the chicks hatch and they mimic a tutor, and usually it's an adult male. You've got female songbirds sing as well. I'm going to talk mostly about male song today. But so typically young chicks will learn to sing from an adult tutor, and it usually occurs during a critical period, and there's some species that then they'll repeat that song throughout their lives.
But why do you said the males sing more than the females?
Not always. It's going to depend on the species. But the primary function of song is to attract mates and to repel rivals. And so in many species you do see that males are the primary singers. There are species, cardinals, males and females sing. I study starlings, European starlings. We can talk more about them, but they're considered major agricultural pests, but they're fascinating from the perspective of singing and communication. And in starlings, males and females will also sing. Females seem to use song when they're competing with rival females. They'll sing to repel other females, and sometimes we see them singing in our aviaries. They will sing, it seems like almost in the same way that males sing. They'll get a nest site and they'll start singing, and perhaps it's to attract a male. I don't know, we haven't studied that. But so the function of song I've gotten into now, you've got mate attraction and to repel rivals. And I'm really interested in the different factors that influence song and why birds sing within distinct contexts. So if you present a male that has high testosterone with a female, he's going to sing like crazy. But not every male will do that. It's only a male that has a nest site, right? So this is male starlings I'm talking about specifically. But a male must first acquire a nest site. And then, if you present him with a female, he will sing at extremely high rates. But interestingly, if he doesn't have a nest site, he's going to ignore that female, right? And it seems to have something to do with testosterone. The steroid hormone testosterone will rise once he gets that nest site. Then you present him with a female and he responds. But it's socially inappropriate for a male without a nest site to do the same thing. It takes a lot of energy to sing. You are at risk of predation. And so males generally don't sing unless they have that nest site. So I think there's something interesting about getting a resource that then allows you to communicate. And it dramatically affects communication. I sort of think that's like me getting this invitation to speak here. Now I'm going to communicate at a high rate. If I didn't have the invitation, I wouldn't. So in some sense, I think you've got some parallels there.
And it takes a lot of energy, hence the beer.
And it does take energy, so I need a carb load while I'm doing this. But then you've got males will also sing to repel other male intruders, and in starlings, my study species, they sing the same song. So the same song that females find irresistible, other males are repelled by that song. And it's interesting, I haven't studied this, but there's a good deal of literature on what it is about song that females find irresistible. And females tend to prefer longer songs with very complex repertoires, songs that males will repeat the elements again and again and again in a very similar fashion. They call it stereotypy. Females like a stereotype song, and the males that produce those songs tend to have really good qualities, a good immune system. They tend to be older males that have had experience. So the females are getting good guys when they pick the right guy, which is interesting. And that's the same guy you wouldn't want to mess with if you were another male. But so I'm interested in why birds are singing in these different contexts, what causes the shift. The other context that I'm really interested in is communication that's produced when it can occur when no other bird is around. So birds will sing sometimes when they're alone, and they sing at very high rates. And I think a lot of people, if you go outside and you see a bird singing at high rates, I've heard people say, "Oh, he looks like he's having a good time." And I think that birds do sing when they're alone because it simply feels good, right? So I'm saying that song in this context is intrinsically rewarding. It would be like you singing in the shower, right? You sing in the shower because it feels good. And it may be that you're singing because you're already in a good mood, but I think that singing is going to make you feel good as well. And so I think the same thing is going on with songbirds. It's very important for young birds to practice, right? They have to sing at a high rate. Now, why would they do that? They're not getting a mate. They're not repelling a male. Nothing is occurring. As far as you can see, other animals are ignoring the song. And I suspect that they're singing because it is rewarding. I think that reward systems in the brain are supporting that kind of song. And I think that the role of reward in singing in these different contexts is different. So when a bird is singing to attract a female, I would suggest that producing that vocalization is not rewarding. Okay, and I'm going to go out on a limb. We've been trying to test this in my laboratory, but I think it doesn't feel good to sing in that context. What is rewarding is that the male attracts a female. He can copulate with the female. That's reinforcing, and that will get him to sing again in the future. And
how can you test something like that?
Well, so that is the question. How do you ask a bird, does it feel good to sing? You can ask a human, and we'll say, yeah, it feels good to sing. And I'll carry this a step further because, as you know, my voice doesn't carry well in bars, which is probably why I'm a scientist again. But I think that I'm communicating with you, and what's going to be reinforcing for me is if you nod your head and you're smiling at me and you find this interesting. If at the end of this people are shaking their head and you know, you guys really show me that you dislike what I'm saying, then I'll be less inclined to communicate in the future. So I think that my producing these words, that doesn't feel good. It's a strain, right? But if I were singing in the shower, it's different. So I think that you've got human parallels as well. So how do you test that? I struggled with that question for about 9 years. And I'm interested, I keep saying, these factors that control socially appropriate communication. And by factors, I'm talking about environmental factors. We know that day length, the starlings that I study are seasonally breeding birds, and they respond to the day length. As day length increases, their testosterone increases, the males acquire the nest boxes, they sing to attract females. So I'm interested in that, the hormones, the day length. I'm also interested in how the brain controls the motivation to communicate in these different contexts. And one thing that I've been looking at over the years is a neuropeptide called opioids. And some of you might be familiar with opioids. Endogenous endorphins are opioids. People talk about runner's high. That involves endogenous endorphins. If you go to the hospital and you're in pain, they'll give you morphine or codeine. All of these are opioids. And your body naturally produces opioids as well. And we wondered at first, could when birds sing, at least when they're alone or practicing song, that intrinsically rewarding song could involve opioid release. So we tried to take blood samples and measure that. And then we also have collected neural tissue, and we find that opioids in particular brain areas do relate to bird song, and they don't relate to the kind of song that's produced when you're trying to attract a female. Right? So males that are singing to attract female, you don't see a relationship between these opioids in the brain and song. But if you look at song when a bird is just singing alone, maybe looking off into space, everyone's ignoring this song, that kind of song does relate to opioids. Question?
How do you know what the opioid level is in the brain while the bird is in the process of singing?
So that's actually been a tricky question with opioids. There are a lot of neurochemicals that you could actually lower a probe and measure release as a bird is singing. In this particular case, we can't do that with opioids. So what we've been doing is we will have the birds singing. So we're studying these starlings. We trap the starlings from farms. Farmers really hate starlings, and so they are trapping them and killing them. Instead of killing them, we'll bring them into the lab and we'll observe the behavior. And then we look at the brain tissue, and we've been able to look at the protein markers for the opioid peptides. And then we can measure how concentrated the opioids are in the brain. So it's a correlation, right? We aren't seeing the actual release as the birds sing, which is something we'd like to do. We've tried to sort of look at that in some creative ways. Opioids are associated with pain reduction, and so we have had birds sing, and they will dip their foot in hot water. So it's not hot, it's not going to burn the bird, but it's warm. You put your finger in and go, ooh, that's a hot bath. It's hot. And so the birds will put their foot in. Some will keep their foot in there for a while, some will retract it quickly. In the first study we did, we had 9 birds, and the graduate student in the lab, she had her bird singing, and she dipped the foot and just say, how long can you keep your foot in the water? And the idea is, if you're singing and it releases opioids, you're going to feel no pain. You're not going to feel this hot water. It's not going to bother you. First 9 birds, it worked beautifully. We had this beautiful relationship. Birds that were singing just kept their foot in the water. Birds that didn't sing much, they took their foot out right away. And then she collected data on, I think, 180 birds, and we lost the relationship. So I know we should have just published the first 9 but we didn't. We didn't. Yeah. So we tried to be good scientists. But so that was one way we tried to ask, does it feel good to sing? And is there a difference if you're singing alone, like you're singing in a shower, or if you're singing to attract, a social kind of reward? So then a common way of studying reward is to use something that's called a condition-placed preference. And this is used frequently in studies of drug addiction. And so if in a lot of the studies you would take a rat, and let's say you've got a chamber. There's one side that's decorated with stripes and one side that's decorated with polka dots. And you put the rat in this side, the stripe side with cocaine. You put the rat in this side with a placebo solution. And you do a couple pairings. And then you remove the partition, you ask the rat, do you like stripes or do you like the polka dot side? And if cocaine is rewarding, they'll hang out on the stripe side. And that is what they'll do. Rats will hang out on the stripe side. So he said, well, can we do this with singing?
Just on a totally tangent that strikes me as is that common to use cocaine as a reward in animal experiments?
In rats?
For drug addiction. Yeah, if you're interested in drug addiction in rats, then cocaine would be used as a reward. And there have been some, this will be off topic, but there have been some studies.
Science Pub does a lot of that.
Yeah, where they've got rats with competing rewards. And you say, does the rat it would be a mother rat who's just giving birth, does she like her offspring? Or does she go for cocaine?
Oh.
And the fascinating thing is right after mother rat has given birth, she goes for her offspring. They are more rewarding than cocaine. And as the offspring mature, then she'll go for cocaine. And I don't know what that means, but what it means is that your brain reward systems are shifting to make what needs to be rewarding when it should be rewarding.
I remember as a kid, I think my mother was similar, but it was instead of cocaine, it was crossword puzzles. Once we got to a certain size, she was more interested in crossword puzzles. I remember going, Mom, what's for dinner? What's a 7-letter word?
Perhaps. Perhaps, I don't know, have you heard of the rat park experiments where, everybody said, oh, look, the rats really love cocaine or heroin or whatever. Look how they prefer it to water. And, well, they were doing this with rats that are traditionally kept in cages. Some Canadian scientists basically built a rat amusement park with, you could find your food, you could mate, you could socialize. Rats are pretty social, especially when they're horny. Now, would the rats from that environment still prefer cocaine to water? Or no, they would try it, but water was just as good. But let me get back to that female rat back there that you just grabbed me away from. I really don't want to drink right now.
Yeah.
So basically, they showed that in a stimulating environment, rats are not easily addicted in crappy environment. Context, I would say, has a lot to do with addiction.
No, I think that makes sense. They've got no stimulation.
Yeah.
And so what are they going to do? They're going to go for what's most stimulating.
As you could imagine, that sort of research was poo-pooed and pushed under the rug because, making a stimulating environment for kids is really expensive. Let's just attack the drug as an evil that sucks people in against their will. But where they've created better environments for kids, they usually prefer to play basketball, go dating than...
No, it isn't. The competing reward, I think, is fascinating, right? And so if you've got a stimulating environment and basketball is available, that's rewarding. It's intrinsically rewarding. So.
And you can pay people not to use dope, and guess what? It works. You can give them a lottery ticket, a chance of winning something if you're give us enough clean urine.
Even if you don't win.
Even if you don't win, the chance of winning is so. But it's context. It's not.
No, the context is key.
As you're dipping these birds, though, did your students' attitude towards the bird get more relaxed? I mean, could it be a more stress environment in the first 9 or 20 birds, and the next 100 birds becomes here, dip?
It is hard. It's hard to know. I mean, I think that people, as they do studies, their criterion will change. And I suspect that she probably, at the beginning, was really careful. And as she went along, I mean, she's a very careful student. So I suspect that she, as well as anyone could do, she may have, it's true. Some people are stressed early on. And then they relax as they go along.
You need stressed graduate students dipping them into. And why warm? Why not a cold presser?
We could have done that as well. There's a study in humans
a lot more research
where they had humans stick their hands in ice water. And they said, how long can you keep your hands in ice water? And this came out when she was doing her foot dip test. And humans can keep their hand in ice water longer if they're cursing.